Have you ever been totally lost in something you love, like maybe a game or reading or just talking to a friend?
Oh,
And then you look up and just hours have vanished. Gone. What felt like, I don't know, 20 minutes was actually half the day.
yeah. And then there's the other side, isn't there? Being stuck in some uh, painfully dull meeting, or maybe waiting for some really important news,
Oh, the worst.
where every single second just feels like it stretches out forever. Like time itself is warping, going in slow motion.
Exactly. That feeling, time speeding up, time crawling, we all know it. But, it's not just a figure of speech. It actually points to something pretty deep about how our brains build our experience of time. And, well, it makes you wonder, is our brain getting time wrong somehow?
That's precisely what we're diving into today. We're looking through the sources you sent over, everything from, hardcore neuroscience papers and computational models to research on trauma, even some philosophical chats online.
Quite a mix.
Yeah, the goal is to unpack how the brain creates this subjective time, why it feels so different depending on the situation, what roles things like emotion, attention, memory play, and ultimately whether we can really call this internal feeling an illusion.
Okay, let's get into it. We feel time like this steady, straight line moving forward, right? Moment after moment.
That's our subjective feeling, yeah.
But the sources immediately point out this sort of tension, this gap between that feeling and what physics tells us.
Right. Physics often talks about time as, well, a dimension, part of space-time. It's fundamental to the universe existing. Some sources even bring up time symmetry laws, the idea that the universe has a direction.
So physical time is real. It exists whether our brains are here or not.
Exactly. It doesn't depend on us perceiving it.
But our experience of it, that's where the brain comes in. And things get messy. Our sense of now, it isn't actually instantaneous, is it?
Not even close. For your brain to give you a coherent picture of what's happening, it has to grab all the sensory information, process it, put it all together.
And that takes time.
It takes time. We're talking hundreds of milliseconds. So one really striking point from the sources is that because of this processing lag, you're actually never experiencing the true physical now.
Wait, really?
You're always living just slightly in the past, processing stuff that's already happened.
Wow, so my brain's present moment is always a fraction of a second behind reality.
Basically, yes.
Yeah.
It's always playing catch up.
Yeah.
And because this perception is something the brain constructs, it's synthesized, it's subject to these delays, these potential distortions. Some argue that our subjective feeling of time passing is a psychological construct.
Okay.
Or maybe even an illusion. Not saying time isn't physically real, but our feeling of it, our internal sense of flow, that's something the mind creates. It's built, not just passively received.
Okay, if it's built, how does the brain actually do the building? Is there like a central clock somewhere?
Well, the sources are pretty clear on this.
Mm-hmm.
There isn't one single master clock in the brain just ticking away like a stopwatch.
No timekeeper module?
Doesn't seem like it. Instead, timing looks like it's an emergent property. It involves a whole network of different brain areas working together, contributing in different ways, especially when you're consciously trying to judge, how long something lasts.
So which parts of the brain keep coming up in this research?
We see areas like the basal ganglia, the supplementary motor area, the SMA, which are often tied to motor control and seem important for timing rhythms or predicting when something's about to happen.
Makes sense for movement.
The cerebellum is also key for very precise timing, crucial for coordination. And then you have higher level areas like the prefrontal cortex, parts of the parietal cortex, the insular cortex. They seem more involved in the cognitive side of estimating duration.
So it's spread out, a distributed system handling different kinds of timing tasks.
That's the picture, yeah. And a big question for neuroscientists is how the activity in these areas actually represents time. How do neurons encode duration?
Which brings us to the models.
Exactly, computational models trying to explain this. The sources mention things like state-dependent networks.
Okay, what's that?
Imagine a group of neurons. The pattern of their firing activity changes over time. The specific pattern, the sequence, represents how much time has passed. It's less like a clock ticking and more like watching a complex shape evolve.
Interesting. Less linear.
Right. Another idea involves ramping activity, especially in the prefrontal cortex. Certain neurons gradually increase their firing rate during an interval. How high the firing rate gets basically signals how much time has gone by.
Ramping up, that feels a bit more like an internal timer building towards a threshold.
It does have that intuitive feel. And speaking of the underlying mechanisms, one chemical messenger pops up again and again in the sources: dopamine.
Ah, dopamine, the reward chemical. How does that fit into timing?
Well, dopamine pathways, especially the ones connecting to the striatum involved in movement and reward, are really implicated in temporal prediction, anticipating when something good might happen. And for a long time, the main idea was that dopamine directly fiddled with the speed of some kind of internal clock.
So the thinking was, more dopamine means the clock runs faster, subjective time feels longer.
That was a common hypothesis, yeah. And some studies looking at drugs that affect dopamine, like stimulants, seem to show effects on time perception that kind of fit with that idea.
Ah, I sense a but coming.
Ah, yeah. But this is where one of the studies you share gets really fascinating and adds a big twist.
Okay, tell me.
They used optogenetics, that amazing technique where you use light to control specific neurons.
Right, super precise.
They used it on dopamine neurons in mice, while the mice were doing a timing task. Now, if dopamine just speeds up the clock, activating those neurons should make the mice perceive time as longer, right?
Yeah.
Because their internal clock finished counting faster.
Yeah, like a fast clock making the interval seem to take up more ticks.
Exactly. But that is not what they found.
No. What happened?
Stimulating the dopamine neurons made the mice judge the time intervals as shorter.
Shorter. Time flew by for them when dopamine was active.
That's what the results suggest, which is completely the opposite of what the simple speed-up idea would predict.
Wow. Okay, so dopamine isn't just a speed dial for the internal clock.
It seems not. It really challenges that simple model. The researchers proposed that maybe dopamine isn't directly setting the clock speed. Maybe it's more involved in signaling things about the timing or the surprise factor of cues, acting more like an intermediary signal that influences how the timing system affects behavior.
So it's tied into expectation and learning, not just raw timing.
It points to a much more complex role, yeah. It shows how intricate this whole neural construction of time really is.
Which I guess ties right back into what we started with emotion, because our sense of time feels so strongly linked to how we feel.
Absolutely. That basic idea, time flies when you're having fun, drags when you're miserable, that holds up pretty well in research. But the sources also draw a really important distinction within that.
A distinction based on the type of bad feeling.
Exactly. One key paper looks specifically at the difference between anxiety and fear. They induced anxiety using that threat of shock method we mentioned earlier.
Right, where you know a shock might happen, but you don't know when. Creates that constant low-level dread.
Precisely. A state of unpredictable threat. And they tested time perception using tasks like the temporal bisection task.
Explain that again.
Sure. Participants learned to label specific durations as short or long. Say 1.4 seconds is short, 2.6 is long. Then they judge durations in between, the point where they're equally likely to call it short or long. That's the bisection point. It tells you about their subjective midpoint.
Got it. So what happened under anxiety?
Under the threat of shock, their bisection point shifted upwards. They needed a longer actual time before they started calling it long.
Which means subjective time felt shorter.
Exactly. Time flew. Induced anxiety led to temporal underestimation. Time felt like it was passing more quickly.
That's fascinating because intuitively you might think anxiety or fear would make time slow down, like in a scary movie moment.
Right. But this study suggests anxiety, specifically the anticipation of an unpredictable threat, does the opposite. It speeds things up. And the paper contrasts this with fear.
How did they test fear?
In other studies, they discussed fear was induced by giving a shock after the thing being timed. So it's more about reacting to a bad thing that just happened rather than waiting for one.
Okay, reacting versus anticipating.
And in those fear-related studies, the evidence for time distortion wasn't nearly as clear or consistent. No strong signal of time slowing down or speeding up reliably.
So anxiety makes time fly, but fear, maybe not so much, or at least not in the same way. That's a really specific finding.
It's a key dissociation they highlight. The researchers suggest it might be about attention. Perhaps anxiety captures attention in a specific way that accelerates the perceived passage of time, while the state of recovering from fear is different attentionally.
So it's not just bad emotion equals slow time. It depends on the kind of emotion and maybe what it does to our attention.
That seems to be a major takeaway. And it's not just negative emotions either. The sources mention awe, for instance.
Awe!
Yeah, feeling awe can apparently make people feel like time is more abundant, more expanded. Maybe because it shifts your focus outwards, away from yourself.
That fits the feeling of awe, yeah. Though I did notice in that anxiety fear paper, they found just looking at emotional faces like happy or fearful ones didn't really change time perception much in their setup.
Good point. Which suggests the context really matters. Just seeing a picture of a scared face isn't the same as feeling personally threatened.
Right.
Other sources also chime in that basic features of the stimulus itself, like how vivid or complex it is, can influence timing too. There's this processing principle idea. Maybe things that are more vivid or easier for the brain to process feel like they last longer sometimes. So emotion matters, context matters, attention matters, which brings us squarely to attention itself.
Absolutely central. How you allocate your attention during some period has a massive effect on how long you think it lasted.
Like if something emotional grabs you, it holds your attention, and maybe time seems to zip by. But if you're bored, your mind wanders. Maybe time feels like it's crawling because your attention isn't engaged externally.
Could that explain the anxiety effect then? Maybe anxiety forces attention onto the threat, making time feel faster.
That's definitely one of the main explanations they propose in attentional account. And here's another cool example from the sources related to attention. Mindfulness meditation.
Okay.
One study looked at longer time intervals, like several minutes. They found that people practicing mindfulness meditation actually overestimated the duration compared to a control group.
Mindfulness made time feel longer. I might have expected the opposite, like getting lost in the moment.
Right. But the effect was linked to participants reporting more focus on the present moment during meditation. This kind of fits with the idea that maybe short interval timing relies more on those clock-like mechanisms we discussed, whereas judging longer durations might be more about cognitive factors, like how much attention you paid, how much information you processed.
Which leads straight into memory, right? Especially when we think back on things.
Critically important. Memory is huge for retrospective time judgments, looking back and estimating how long something took after it's over.
And how does that work?
Those judgments seem heavily influenced by how much stuff, how much information, or non-temporal content your brain packed into memory during that time.
So if more happened, more memories were made.
The interval feels longer when you look back on it. Think about a really busy, eventful holiday versus a quiet week doing routine stuff.
Right. The holiday feels like it lasted ages in retrospect, even if it flew by at the time.
Exactly. The classic full week feels longer looking back phenomenon.
Yeah.
Your memory is just richer with distinct events.
Makes total sense.
And the hippocampus key for memory formation is also involved here. It helps structure our experiences into temporal episodes. And the sources note that even within our memories, time gets warped. Things that happened within the same mental episode feel closer together in time than things that happen across different contexts or episodes.
So memory doesn't just store the past, it actively shapes our perceived timeline of it.
Precisely. It's
Yeah.
all part of this active construction. And it's not just our internal state. Even basic properties of what we're perceiving matter.
Like you mentioned vividness.
Yeah.
What else? Size.
Yeah, size is mentioned. Also things like complexity, how fast something changes. That processing principle, again, may be more vivid, easier to process things feel longer. Things that change faster or constantly are often judged as longer than things that speed up or slow down gradually. And yes, bigger visual things can be judged as lasting longer than smaller ones, even if the actual time is identical.
That's nuts. So my brain isn't just running a timer, it's integrating sensory details, how hard it's working to process things, my emotional state, where my attention is, what memories it's laying down. It's building this whole complex picture, and time is just one aspect of that construction.
That's a great way to put it. It really emphasizes how dynamic subjective time is, how easily it can be pushed around. And this, unfortunately, becomes really apparent and significant when we look at trauma.
Right. The sources brought up temporal disintegration. What exactly is that?
Temporal disintegration is discussed particularly with collective trauma, like the pandemic. It refers to this fragmented, disrupted sense of time.
How does it feel?
It involved distortions like feeling time has slowed right down or days blurring together so you lose track, and this deep uncertainty about the future.
I think a lot of people felt that blur during lockdowns, didn't they?
For sure. And the sources are clear. Experiencing this temporal disintegration is strongly linked with worse mental health outcomes. Trauma can also lead to feeling stuck, like the past trauma is still happening or constantly repeating, a kind of timelessness, but in a negative way.
That sounds incredibly distressing and disorienting.
It is. Temporal disintegration is also tied to feeling like you have a foreshortened, uncertain future, the sense that the future is brief and unpredictable. This really undermines well-being. Assessing these time distortions is seen as important for spotting people at risk after trauma.
So understanding these subjective time warps isn't just, a cool neuroscience puzzle. It has real clinical importance.
Absolutely. Knowing that anxiety seems to make time fly could give us new ways to understand what it feels like to live with an anxiety disorder, maybe feeling overwhelmed or like time is constantly slipping away.
Hmm.
And recognizing trauma-specific effects on time, that disintegration, that foreshortened future could help us develop better ways to identify and support people who are struggling and might be at risk for longer-term problems.
And there was also that point about just general well-being, wasn't there? Feeling like you have enough time.
Yes, perceived time adequacy.
Mm.
Feeling like you have sufficient time is linked to being happier day to day and experiencing less distress.
It really drives home that our internal sense of time, however subjective or wrong compared to a clock, really matters for how we feel and live.
Definitely. It profoundly impacts our emotional state.
So, back to the big question. Does the brain perceive time wrong? I mean, listening to all this, it feels less like the brain is wrong and more like it just wasn't built to be a perfect atomic clock.
Yeah, that seems fair.
It's constructing this subjective experience, this feeling of time that's incredibly fluid, easily shaped by our neurochemistry, our attention, emotions, memories, even just how bright or big things look.
It's a dynamic synthesis, pulling together signals from all over the place.
Yeah.
Which means, yeah, our internal sense of time is almost never going to be perfectly synchronized with external physical time. Call it an illusion, call it subjective interpretation. Whatever it is, it's not a direct readout of reality.
It's like the brain's running this constantly updating simulation, its best guess to make sense of duration within experience.
A simulation that's always being tweaked, always prone to these interesting distortions.
Okay, so here's the final thought then, the really provocative bit. If our subjective time is so easily warped, if it's this construction built from attention and emotion and memory, what does that actually mean for us? For how we plan our future based on past experience? How we define ourselves right now, if time isn't fixed but constructed? Could learning to manage our attention, our emotions, how we process memories, could that, in a way, give us more control over our experience of life itself?